Today I am going to take class on power of lens and also function of eye. So in my previous class I already discussed what is light and what is the lens and what are the type of lens. So today the topics I have chosen, have written here all day on the board. Look at carefully all of you. So first of all, what refraction of light, law of refraction, refractive index of light and formula for refractive index. I am going to discuss about that these four terms first. So for that reason, if I draw the diagram of refraction, like light source, light is falling from here to there. This is a point of incidence. So light is falling from here to here, and there is an imaginary line pass through it. This is the air, this is water. So light is falling this way. So this ray is called incidence ray. So this incidence ray is hitting the incident point. So after that, you know, the air is lighter than the water. That means water is denser than the air. So when it comes out on the other side, because both of the medium are transparent, so when it is coming out on the other side, it will bend towards, without going straight, it will bend towards the normal. And what is normal? The perpendicular drawn on the line of separation. This is N. And the light incidence ray falling on the line of separation, that the point of incidence, that is refracting without going straight, it is bending towards the normal. So it is coming towards the normal, and the incidence ray is creating an angle with the normal, and also refracted ray also creating an angle with the normal. So now the question is, what is refraction of light? Refraction of light is the capacity of the lens to bending the light, that means diverging and converging of lens, light rays through the lenses or the mediums is called refraction of light. Okay, look here, upper one is, medium is air, bottom one is water. When light is falling in the line of separation, they are bending towards the normal, that means it is changing its direction. So this changing of direction is called refraction of light. Now come to the next one, law of refraction. Now look here, what is the name of this light? Incidence ray. This one is refracted ray. Look here, we are talking about law of refraction, and here the incident ray, refracted ray, normal, that means the perpendicular, all in point of incidence. What is the name? Point of incidence. All these three things are lying on a same plane. Clear? Incidence ray, refracted ray and normal, that means the perpendicular, all lying in same plane. This is the first law of refraction. Now come to the second law of refraction. Look here, the incidence ray create an angle with the normal, that can be named by small I. And here the refracted angle also create an angle with the normal, and it can be named by R. So these two angles are always constant. Whatever the change in your incident angle and the refracted angle will be changed, then this will always be constant. And this is the second law of refraction. Now come to the another important term, that is called refractive index. So what is refractive index? You know, the light is passing, when refraction occurs, always the mediums are transparent, and the different kinds of mediums are made up of different kind of molecules, and some are dense and some are denser, some are lighter, and the amount of molecules is more in dense medium. So when something is passing through a lighter medium, there has to cross little amount of molecule, and the light will travel faster. So that in that case is velocity. And when light passes through a denser medium, it has to pass through many molecules, and that is also shape and polarization of the molecules has to pass through. That's why the refracted angle, if it is passed through a denser medium, it will its velocity will be less and always come to the close to the normal. That's why it takes time more and it bends towards the normal. This is called refractive index. Okay. Now come to the formula for the refractive index. Every medium have a definite refractive index. The refractive index of water is 1.00 and water is 1.33. So using the formula, that means if I give this medium name is N1 and this one given to N2, what will happen? The formula, it will be like this: sin theta I equal to sin N2 sin theta R. Using this formula, you can find out if any one angle of the value is known. If you know one of the angle's value, suppose this one is 55 degree. So what would be the refractive angle? Writing the formula again here, look here, N1 I equal to N2 sin theta R. Yes, we talked about the other points. What are those? Then conversing and diverging of light. Conversing of light rays. You know, conversing of light rays occurs to the convex lens. Can you remember which kind of lens is called convex lens? And the lens is middle part is wider than the edges. These kind of lenses are called convex lens. So what happens in convex lens, when light falls from any kind of object, suppose okay, the light, suppose there is a person and from here light is falling. So always the light rays are parallel to one another. So when it is passing through the lens and coming out on the other side of the lens, what happens? They cannot stay anymore in parallel. So they all come together and meet at a point on the principal axis. So what happens? The light rays will come here, okay. So see here, when the lights are falling, that means incident rays that is coming from the object, those are the reflected rays falling on the lens. Which kind of lens? It is convex lens. After, when they are coming out on the other side of the lens, they are all coming together and meet at a point which is called focal point. And the distance between and the line, what is called principal axis? Can you remember? The principal axis, the line passed through the lens, touching the center of the lens. That is called optic center or optical center. The line which touch optical center, that line is called principal axis. And see, all the refracted lights are coming at a point. Okay, and the distance between this and here and here is called focal length, and this one is called principal axis. this is focal length and this is optical point. Focal point, focal length, and these are the incident rays. Okay, and this lens is convex lens. That means converging of light occurs to the convex lens. That means the light falling, the reflected light falling from the object on the convex lens, then they are coming out on the other side, and without staying parallel they have to come at a point. This phenomenon is called converging of light rays, and for this reason the convex lens is called converging lens. Now come to the next one, diverging of light rays. Okay, this is maybe think this is the optical center. The line is passing through this, that is the ray of light falling from the object, that is the reflected light. This is called principal axis. What happens? All the lights are falling parallel. These are incident rays. When they are passing on the other side, without them they are staying parallel, they are going far away from one another. Okay? So just the opposite of the converging. So this phenomenon is called diverging of light rays. So now how we can find out the focal point, focal length? Is it possible? But they are not meeting at a point. Yes, there is a way. If we draw the line backward, they will all meet at a point. Okay, and this point is called focal point, and the distance between this and this is called focal length. Here, optical point to the focal point, the distance is called focal length. Okay, and this is called principal axis. These are diverging rays through the which kind of lens? This is a concave lens. Clear? These are the incidence ray, and these are the refracted ray. Okay, those are all traveling in this way, and these, when light falling in the on the lens, they are coming out on the other side without staying parallel. They have to go far away from one another, and this phenomenon is called diverging of light rays, and it occurs in concave lens. Okay, that is the diverging of light rays. So let's go for the next one. Our next term is power of lens. What is power of lens? The converging and diverging capacity of the lens is called power of lens. Power of, suppose this is the lens inside our eye. Okay, so light rays are falling from the object in this way. So if the retina of the eye is our here, so focal normal eye, the converging power will be at a point on the retina. Okay, so normally normal eye can see the object clearly when the focus point is on the retina. If somehow converging power of the lens increase, see, they become more close. That means their converging power increased. So for that reason, focal point is in front of the retina. So in that case, the object, the image of the object is not falling on the retina is present, optical nerve, and there are different kind of cells present which are receiving the signals from the image creating on the retina. But if the focal point is in front of the lens, they are not getting the information what is happening on the image. So people cannot see properly. So this converging and diverging power of lens is called power of lens. More, when the converging power become less, that means decreases, then focal point will be out of the eye. So is there any nerves, opticals, is there any cone cell, rod cell can receive the signals? No. So people are power of lens. What is the unit of power of lens is called? It is called diopter. The formula for the power of lens is P equal to 1 by F. So what is diopter? Diopter is the unit of power of lens, and focal length should be is the proportional with always the unit of 1. So that's why power is proportional 1 by F. Clear? So here the P is the power of lens, F is the focal length. So if you know any one of the values, then you can find the value of the power of the lenses. Suppose if I show you one workout here, 2D. The power of lens is 2D. What does it mean? It is occurring in concave lens or in convex lens. So see the plus sign, you can consider that this thing occurring in the convex lens. So putting the values of 2 instead of P, we can work out this. 1 by F, 2F equal to F equal to, directly I am doing here 0.5 meter, and always consider focal length in meters. So or you can convert it into 50 centimeter, doesn't matter, but always work out in considering the measuring unit meter. So if it is the power is even minus 2D, what will happen? That means seeing the minus sign, you can understand this is the power of which kind of lens? That is concave lens, and it is the power of convex lens, and it is the power of concave lens. So same, the formula will be same, P equal to 1 by F. So putting the value of P minus 2 equal to 1 by F. So therefore F equal to minus 0.5 meter. That means focal length is minus 0.5 meter. In centimeter it will be minus 50 centimeter.